Welcome to EPT DSA challenge number 11. So what this particular challenge saying is, one array is there, name is A, which contains zeros, ones and twos. There is one array which contains zeros, ones and twos. Now you have to sort that array, means 0 should come first, 1 should come next, 2 should come next. So means simply you have to sort the array. How much time? This array contains n people is you. Given an array A consisting of zeros, ones and twos, and one more thing is array A contain n elements assume. Contain these kind of people. You have to sort this array. How much time? What is the time complexity for this? How will you solve? Simply sorting an array. Simply sorting an array. What is the way? But it is a special kind of array. Maybe special sorting technique you can implement. It is a special kind of array. So special sorting technique you can implement. One array is there consisting of zeros, ones and twos. The task is to sort the array. That is, put all zeros first, then second, then third. Right? Like that. Zeros, ones, twos you have to keep. Suppose if I take one example like, right, array A contain these elements. Let's take some 10 people. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me take the some values. 2, 0, 1, 0, 2, 1, 0, 0, 1, 2. Like that some elements are. So if you sort this array, it should look like this. If you sort this array, it should look like this. So if you sort this array, how many zeros are there? 4 zeros. How many ones are there? 3 ones. How many twos are there? 2. Right, like this. So sorting, simply sort. This is the answer. So what is the answer for this? You may say that, sir, how to solve this problem? I think just sort. Apply merge sort and sort. Or apply heap sort and sort. So merge sort or heap sort will take n log n time. Every case. Right? If you want, you can go for heap sort. Right? N log n time. Right? Every case. Merge sort. But merge sort is having the one problem, that is it may take more space. Merge sort is not in place, it is out place. So if you want to merge, if you don't want to merge sort, go to the heap sort, which will take which will take less space. Right? So time complexity order of n log n, depending upon which sorting algorithm you will apply. Merge sort will take time complexity n log n. Merge sort, depending upon the sorting technique, space may increase, space may decrease, something like this. You can go for merge sort, you can go for heap sort. If space is a problem, go to the heap sort. Go to the quick sort. Right? Go to the quick sort, but quick sort worst case is n square. Right? That is the reason time complexity, by thinking I written the merge sort. It's okay. Simply time complexity n log n. Now let's come to, because there are some better approaches are there. Here you no need to bother. One answer is just simply sort, apply merge sort. Right? One more algorithm. I think very interesting. This algorithm everyone knows also. Let me write. So I'm taking the same example again. Same example once again I'm taking. Right? Don't worry that much about the previous one. Simply sort. But if at all so many elements are there, so many different types of elements are there, you can sort. But special people are there, 0, 1, 2. Then will you follow normal sorting algorithm? There is a one better approach. You can see this. There is a one better approach. I'm going to explain. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me write 2, 1, 0, 2, 1, 0, 0, 1, 2, 0. some numbers, right? What the one way is, listen, one way is very simple. One way is see everyone now. One way is take three variables. Count zeros, count ones, count two. Take three variables first. Initially all are zeros. Now what you do is in the A array, 2 comes, increment the 2's. 1 comes, increment 1's. Zeros comes, increment zeros. 2's comes, increment. 1's come, increment. Zeros comes, increment. Zeros come, increment. 1's come, increment. 2's come, increment. Zeros come, increment. So like that. Totally 4 plus 3, 7, 7 plus 3, totally 10 people. So now after incrementing, I think one scan is over. One scan is over. You got to know how many zeros, how many ones, how many twos. So take one for loop 4 times, take one for loop, see 0 times, means 4 times, store zeros. Let me use another color. Take one for loop, C0 is 4 times only that loop. Store all zeros first place. Next one, take one more loop, C1 times only, 3 times, store ones. Take one more loop, right, C2 times only, store twos. Over. So these all three combinedly will take one more n. Totally 2 scans you done, 2n time. So order of n. Every case. Interesting thing is you are not taking one more array. Within the array you are managing. So order of one space. Order of one space. Because you are not taking one more array. Same array you can adjust. Same array you can adjust. So I think same thing I written in the form of a program also you can check. It is a main program. It's okay. From main program, sort function is called. Go to the main program. From the main program, sort function call. See the sort function. Nothing. I am not done anything. I just took one for loop. Whenever it is going on, I am counting how many zeros. I am counting how many ones. I am counting how many twos. So as per our problem, this came 4 times, this came 3 times, this came 3 times. Now I took right 3 for loop. First for loop is C0 times. Second for loop is C1 times. Next for loop is C2 times. Next for loop is C2 times. C0 times, C1 times, C2 times. I hope everything is fine. So this will take n time. This will take n time. Overall 2n. So overall order of n. This is the time complexity. Space complexity order of 1. If you want, you can check. Everywhere I am using array A only. Everywhere I am using array only. I am not taking one more array. I am not taking one more array. Everywhere is array A only there. So order of 1 space. This is the one of the nice algorithm comparing previous one. Don't think much about previous one. There is one more algorithm is there. I think here you done 2 scans, 2n, right? But 1 scan also you can do it. 1 scan also, just managing the variables. So how one more, right? How it is, let me check. Careful. This is array. Within 1 scan you can do it. I will try. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us assume that elements are these. These are the elements. These are the elements assumed. Some elements like this. So what you will do is, let's take 3 variables first. So let us assume that, right, bigger one, right? Bigger index is assume that high. Lower index assume that L. In the same place, keep the M also. Lower place, keep M also initially. Right? So 3 pointers, 3 variable or 3 pointers you take. Or 3 variables. 3 pointers or 3 variables. Where low and mid initially 0th index. Right? Initially. So high is there at the last index 9. Right? So remember everyone, low purpose zeros, mid purpose ones, high purpose, right? I think two's purpose high. This is the basic purpose why I take 3 variables. Zeros purpose low, one's purpose mid, two's purpose high, right? That is the basic purpose. Now you can see one time. What within one scan I have to do. So whenever if it is 0, right? So a of right. So a of 0. This one. Whenever value is 0, see this one. Value is 0. Then what you do is spare if at all value 0. Value 0. Right. This one. Value 0 spare right. Low and mid. Low and mid. It's a low. It is a mid. If you want, you can keep low and mid. Whenever it is 0, swap A of low, A of mid means swap itself. Swap itself, right? And not only that, low also increment, mid also increment. Whenever 0 comes, swap A of low, A of mid. Right? Afterwards, increment also. Right? What is the reason? You will see that. Next one. In the similar way, again check 0. Same. A of low, A of mid swapped. It will be swapped inside. Then M also increment, L also increment. Next. If it is 1, remember 1, case 1. If it is 1, then what you do is only mid only will increment. If it is 1 again, mid only will increment. That's what I said to you. Low meant for zeros. Right? Mid meant for ones. Low meant for zeros, mid meant for ones. H meant for twos. Careful. Right? Next one. Whenever 1 coming, increment. Now see, 2 coming. Whenever 2 coming, every one now 2 belongs to high. Then what you do is swap A of mid, A of high. Whenever 2 comes, swap these two. 2 here, 0 here. But remember, after swapping, high only will decrement. High will become here. Again, same story you see. Again, same story because mid is not incremented. Again, check. Is it 0? If it is 0, you know very well. Mid and low should be swapped. Then afterwards, low also increment, mid also increment. Whenever 0 comes, very simple. Whenever 0 comes, low and mid swap. Low and mid swap. Then low will increment, mid also will increment. If 1 comes, only mid increment. If 2 comes, mid and high both will be swapped. Afterwards, high will be decremented. Afterwards, again 1. So mid will increment. So remember, at any point of time, comparing mid and high will be greater. Mid and high, mid less than high. Right? Until this condition happened, continue. So this is the same story. See, mid less than or equal to. If equal also, you can stop. Whenever both are equal, you can stop. So what I mean to say is, if at all 0 comes to do this, if at all 1s comes, do this, if 2s comes, do this. Whenever zeros comes, low and mid both will right swapped and incremented. First to swap, then increment. Whenever twos will come, mid and high will be swapped, high only will decrement. Whenever 1 will happen, only mid will increment. right? If you do that within one scan, you can manage it within one scan. So finally, one scan, so order of and time. So time complexity every case. What about space? Order of one. It is a better one. Previous one, this one same asymptotically, but mathematically little bit difference. It is the space. Space complexity this much. I hope you got it. Simply little variation to the previous one. For this one, it is a little variation. It is a little variation. Right? Please careful. Within one scan, you can manage it. I hope you got it. Yeah. If anyone find out any one more interesting one, please let me know. First approach is sorting. Second one is two scans. Third one is one scan. One scan you can manage it. Right? For second one and third one both are similar, asymptotically, but mathematically little bit different. Little bit. Yeah, fine, perfect. Any doubt there in the comment section you can type. We will see those, and if any improvement is there, we will let you know.